other bases, right? The log key on your calculator calculates the base 10 logarithm of whatever number you put in, right? Can you put in a number, hit the log key, and then, in your mind, change the sign? Because that's what the negative out front does. If the logarithm is negative, then the pH is positive. If the logarithm is positive, then the pH is, and we can have negative pH. Okay? Now, what is that? In chemistry, square brackets mean concentration in moles per liter of whatever's inside. Concentration in moles per liter. It's molarity, isn't it? This formula is often written like this. What's the M mean? Molarity. It's often written like this. Watching? When they don't want to talk about hydronium ions. When they don't want to talk about Bronsted-Lowry acid-base theory, hydrogen ion transfer. They don't want to talk about hydronium ions. They write it like this instead. That's where pH, that's where the H came from. It's about hydrogen ions. Really, it's about hydronium ions. Okay? What's the little p? And it is lowercase p and uppercase h. The lowercase p is what we call in mathematics an operator. When you see the lowercase p, you take the log and change the sign. In this case, we're taking the log and changing the sign of the hydronium ion concentration. Okay? There are other places where we use the p, little p operator in chemistry. It's not important to us to know that. How are we doing? Okay? Now, pH is a way of measuring hydronium ion concentration. Yeah? It's what we call a logarithmic scale. We know logarithms are exponents, aren't they? Right? So, for instance, the difference between a pH of 1 and a pH of 2 is 10 times the concentration of hydronium ion. Difference between a pH of 1 and a pH of 3 is 100 times difference in the concentration. Difference between a pH of 1 and 4, 1,000 times. One concentration is 1,000 times the other. It's a logarithmic scale because the range of hydronium ion concentrations is huge. It goes from about 10 moles per liter down to about 1 times 10 to the negative 15 moles per liter. 16 orders of magnitude. Huge range of numbers. And what do we do when we have a huge range of numbers? We often make it into a logarithmic scale. Instead of going from 10 to 1 times 10 to the negative 16th, it goes from negative 1 to 15. That's what it does. So you know the pH scale goes from 0 to 14. Yeah? It really goes from about negative 1 up to about 15. It's just that those are such extreme concentrations, one way or the other, that we don't usually run into those. That's why it's most commonly shown as a 0 to 14 scale, right? Okay? Now, which one has more hydronium ions? 0 or 14?
No, I was
I
kidding.
think it would be. But it's not, huh? You know that 0 is, starts with an A, acidic, and 14 is basic or alkaline. Now, an acidic solution has a lot of hydronium ions in it. An acid, however, is not acidic, as we'll find out. The terms acidic, basic, and neutral refer to a balance between hydronium ions and hydroxide ions. We'll start this conversation and have to continue it next time. Here's the thing. You watching?
Why?
Water is 1.5.
Here's what this equation tells us. Two water molecules can bump into one another, and one of them will take the hydrogen ion away from the other. Now, why would that happen? Is water an acid?
Yes.
Is water a base?
Yes.
And occasionally, not very often, occasionally, water molecules bump into one another and exchange hydrogen ions. And when they do, they make hydronium ions and hydroxide ions. Just not very many. Does pure water conduct electricity? A little bit. Because pure water is not pure. What's it got in it? A small amount of hydronium ions and hydroxide ions. Now, real quick, come back. This is an equilibrium. This equilibrium strongly favors the left-hand side. Most water molecules do not lose or gain hydrogen ions in a liter of pure water. Only a small number. How many? About 1 times 10 to the negative 7 moles per liter of each. That's 1/10,000,000th of a mole per liter. Not very many. But folks, what's the logarithm of that number? -7. And when you change the sign? 7. So the pH of pure water is 7. They just didn't pull that number out of their butt, you know. It's 7 for a reason. Did you ever look and go, yeah, why 7? Why not like 10? You know, 100? You know, some nice number. It's 7 because the concentration of hydronium ions in pure water is about 1 times 10 to the negative 7 moles per liter. Take the log, change the sign, you get a pH of 7. Now, folks, come back. Don't come back. Hello, where's she coming at you? Let's do the front side, the first 11. How many are you doing? 11. First 11. Don't take this home without taking your acid base table with you, right? Well, like using it tomorrow.
Log is the opposite. My name is Brian.